In this video, we'll look at the mean. The mean, or arithmetic average, is found by adding the data values and dividing by the total number of values. So the mean of 3, 2, 6, 5, and 4 is 3 plus 2 plus 6 plus 4 plus 5 all over 5, which is 20 divided by 5, which is 4. Data values are represented as x sub n, where n is the position of the data value in the list. In the above example, x1 is 3, x2 is 2, and so on. To show the sum of the x values, we use the symbol sigma, this is the capital Greek letter, and sigma x means to find the sum of the x values in the data set. Sometimes the pages just don't want to separate, you know. The mean is the sum of the values divided by the total number of values. The sample mean, denoted x bar, is calculated using sample data. The sample mean is a statistic. So x bar equals x1 plus x2 plus so on and so forth up to xn, and it's divided by n. So we write that as sigma x divided by n, where n is the total number of values in the sample. The population mean, denoted mu, is another Greek letter, is calculated using all data values in the population. The population mean is a parameter. Mu is equal to x1 plus x2 plus and so on and so forth up to xn divided by n. So that is again sigma x divided by n, where n is the total number of values in the population. So these are calculated exactly the same way. The only difference is that one is a statistic and the other is a parameter. Here's a rounding rule for the mean. The mean should be rounded to one more decimal place than occurs in the raw data. If the raw data are given in whole numbers, the mean should be rounded to tenths and so on. Here's an example on avian flu cases. The number of confirmed flu cases for a 9-year period is shown. Find the mean, and here are the data. 4, 46, 98, 115, 88, 44, 73, 48, 62. So for our solution, x bar is, as always, sigma x divided by n. So we add up all of those data values and divide by 9. That's 578 divided by 9, which is approximately 64.2. The mean number of flu cases over the 9-year period is 64.2. To find the mean for grouped data, as in one of our frequency tables, first make a table as shown. We'll have 4 columns, the class or class boundaries, the frequency, f, the midpoint, xm, and then our D column will be the frequency times xm. So step 2 is to find the midpoints of each data class and place them in column C. Step 3 is to multiply the frequency by the midpoint for each class and place the product in column D. Step 4 is to find the sum of column D. And step 5 is to divide the sum obtained in column D by the sum of the frequencies obtained in column B. Formula for the mean is x bar equals sigma of f times x sub m divided by n. When I put the f times x sub m in parentheses, that means we do the multiplication first and then add everything up. So as an example here, we're going to look at the salaries of CEOs. The frequency distribution shows the salaries in millions of dollars for a specific year of the highest paid CEOs in the US. And we're going to find the mean. So our class boundaries are from 15.5 to 20.5. The data is all right there. I don't need to read it all out for you, but we have the class boundaries and we have the frequencies, and we can see that the total of the frequencies is 25. So then we're going to build our table. I've done steps 1 through 3 all together. I start by, I've got my class boundaries and my frequencies. They still add up to 25. I find my midpoints by taking the averages of the endpoints of the class boundaries. So those are going up by 5, starting with 18. So 18, 23, 28, 33, 38. And then f times xm, I just multiply together the frequency by the midpoint to get 13 times 18 is 24. 6 times 23 is 138. 4 times 28 is 112, and so on. And so the total of all of these products of frequencies and midpoints is 555. And I'm going to point out for those of you following along in the book that the second to last f times xm value for the 30.5 to 35.5 row is incorrect. It says in the book that it is 38. It should be 33 because obviously 1 times 33 is 33 and not 38. So I calculate x bar. It's the sum of the products, which we've got down here, divided by n, which we've got right here. So that's 555 over 25, which is 22.2. So the mean salary is $22.2 million.